Today we'll talk about strategy pattern with lambda expression. But before that, will refresh our knowledge on polymorphism. So this is the standard polymorphism example. Abstract class is declared with animal, and dog is extended from animal. So dog is animal. Cat is extend animal, so cat is animal. So is a relationship. Now here in the main method we can create a dog object like this, new dog, okay, and assign to the animal which is the parent, okay, and then although it is assigned to the animal, but we can say my animal dot get sound will give me that animal sound, that animal, in this case the dog sound. So it knows which one to call, okay. So it's on runtime it decide which one to call. So this is the polymorphism. So if you make an array here also, you can see doesn't matter which one to, it will automatically call the correct one. So we are familiar, most of us who are Java developer, we know that this is the polymorphism, how polymorphism work. But I am talking another one. It's similar to polymorphism, but it's not a polymorphism. But the idea is same. Like the parent is assigned, and then parent is assigned, but the action is on the child. The similar things I can see here, the map function. Here animal is the parent, and dog is extend animal, cat is extend animal, which is dog is animal, cat is animal, like previously. Now we say the map here in this case, map, we are creating a hash map, and the class is any type, any class type. So in my and this is the string is the, it could be bark and mew. So here I'm putting map is I'm putting dog class, another one is I'm putting cat class. See here, dog and cat are child of animal, so dog class is also animal class, okay. But here I assign, like previously I assigned to new dog, like the parent is assigned to the child, okay. But here I sound map dot get, here I look at this dot my animal dot get class. This is interesting. My animal is the parent, but we say get class, so it doesn't give me the animal one, it give me the, on runtime it give me the dog class, dog class, okay. So that's why I'm selling that at runtime it determines to use dog class through animal, okay. So similar to this one, at runtime it decide which one to call, see. But similarly this one at runtime it understand which class it was, at runtime it determine this is the dog class, okay. So this is the map. Through the map I can do the resolve the class during the runtime. We can with the map, we can then at runtime we can decide what is the class, okay. So this idea I will be using in my strategy pattern, like at runtime which will know that what is the class. We'll learn the strategy pattern with the payment processor. So why it is a strategy? Because this is the map class extend payment. Payment is the interface, and the payment is the interface, and interface has 3 records which implement, and it dynamically it resolve which one to call. So once it is called, for example if it is called this one, so it dynamically resolved. So that's why it is a strategical pattern, because when it's dynamically resolved, it also knows the which code to run. So in this case, whether this code to run, okay, this is the code, and whether this code to run, it is dynamically resolved. So that's why it's a strategical pattern. So how it is done, it is done through like map class extend payment, as mentioned before, and this is the key. If you look at this is the key and this is the value, okay. And then we say yesterday map, the hash map, so key value, so this is the key and this is the value. So in this case, this is the value, see here, this and this one and this one are same. So here I'm defining into value, okay, and okay, and then all of them. So this one is credit card report function, this is value. This was the other one, PayPal report function, okay, and crypto payment report function. These are all value of this one, okay, key value. Now here strategy map is a hash map, which I mentioned before. This is the strategy map, hash map. And then here I'm putting credit payment dot class, okay, credit payment dot class, and this is the function that I previously mentioned. This is value, all the values, okay, respective map. So the key value. Now question is why it is credit payment dot class, okay, dot class, because the reason is dot class. This is for the because whether it is credit card payment or PayPal payment, it is dynamically resolved, and payment is the parent class. So all of them are parent class, and in the strategy map, when you see there, in this one, when payment class will be passed, and then that whether which one to call, it will be dynamically resolved. That's why dot class was passed, and that, and from how it is, like here payment is passed, and then is a payment dot get class, okay. That get class will give me whether this one is credit card payment class, payment dot class, or crypto payment dot class. So this all will do it, but we don't know what will be coming here, okay. This is the runtime, because this is the parent. So at runtime we'll decide which one is coming. So that's why I had to add this one to as a key. It is a key. So this key is this, okay. Now you understand overall idea. Now little bit go back the code, my step by step kind of. So why I did the static here, because the reason is that this is class level. We don't need to instantiate this one. We run it before the main function is called. So this is kind of initializations things. Everything will be initialized, okay, at the beginning. And this map will also initialize a strategy map. The hash map will be initialized. Once all these are initialized, then like for example, I probably I can debug it here. See, it is coming here. Look, for example, go back here. So it should come this one first. See, it's coming first. Then that's why I'm telling that this is the initialization. Later on we'll come to main function statics, okay. So anyway, so once you come here, then you create, at this point we create the object, credit card payment object, with passing this parameter, which is name and value, okay. And this is actually record. So record means it is a canonical object, and that means it is the data class only. The main idea is to keep the data immutable data. It is final, and there is no set or get. So it is this credit card payment is immutable data. PayPal also immutable data. So look at this one. See here, see record. So it creates immutable data object. So it's called canonical object. So all these object is created. Okay, card. Okay, these object all created, and basically why it now each object, then we this is the regular stream of stream iterating, and each iterating I'm payment and dynamically I'm passing the payment. It could be credit card payment, PayPal payment, crypto payment, because it is the first one will be credit card payment. First time it will send credit card payment, second time it will send PayPal payment. Okay, for example, if I say credit card payment here, so go to here, say here credit card payment. So here, see, the payment is the parent. So in the previously I told that this is the parent. So always we know in the parent I can refer to child. So here is child. So here is credit card payment. So credit card payment come here, but dynamically it is of .get class will give me payment .get class will not give me the payment class. It will give me the credit card class. Okay, that's the real one will give me. The previously I explained here like this in my code. The same reason. Where is my okay here. See here, animal new doc, and then my animal gets sound. So this will come dog. The similar reason it's coming. It is passing parent credit card payment, but it will give me the payment.get class. If it is credit card payment, it will give me the credit card payment class. And this is the key I previously set here. Payment.get class is the key here. I see credit card payment class. This is the key. So once this key is found, then return the credit card payment report function. Okay, that's the normal things. The key value pair. So that get will give me this credit card payment function. Okay, and so this is the credit card payment function. For example, this credit card payment function is strategy. We call, say here, function and payment report. This is strategy. Is credit card payment function. Okay, it is returning me this one. Okay, this function. Okay, let's go there. This is returning me this function. Okay. So this function, what this function takes? This function again takes payment as argument and return this. See, it takes this function and return this. So it means to call this function, we need to send some argument. What argument I need to send? I can send it credit card payment, this argument, or crypto payment like this. So here see here strategy. Okay, strategy null. This is okay. Okay, if it's not null, then this one is I'm sending payment. Here I'm sending the credit card payment in our example. So when you send the apply, when you send this apply function in the credit card payment, then what it does, because we know that as a functional interface, we know that this will actually, by apply, it will run the code. It will run this code. Once we apply it, then it will run this code. Okay, so payment is credit card payment. Again, secondly, every time we'll send the PayPal payment. Okay, here if it is PayPal payment, then it will run as a PayPal payment. It will run this code. Again, when I send the crypto payment, that will run the code. So it means that it is dynamically deciding which code to run. Sometimes it's coding running this code. Sometimes it is running this code. Sometimes it's running this code. That's why it is a strategical pattern. Which code to run is decided dynamically on that is on runtime. here, here, strategy dot apply payment. This payment all three could be, and it's dynamically decide which one to run. Okay. Good about it is we, without changing the logic, we can easily add a new business logic for this one. Like for example, if you want to add a new one, so I just copy this one, like copy this function. Look, let's do it like this way. So like do it record first is better. So the record, we are creating a new record. Okay, let's call, say it is called 1. Okay, crypto payment 1, and then it should permit it because this I have also mentioned that only this I can permit, so I can add more and more the interface. So this is, and then I know this is the function, so I copy this one to another one, and make it like this 1. Okay, and this crypto payment 1. Just I create this record, and this is of course crypto payment 1, and then and then I have to do this is the new one. I am just putting key value pair that I have to copy paste because it is the new one, and okay, crypto function. Okay, and then that's it almost. So here I think anything else I'm missing? Crypto payment strategy map. Okay. Oh, I have to create a new one. So new crypto payment is here. New crypto payment 1, this one. And if I run this program, it should work. Yeah, it's working. So this crypto, name it crypto 1. So let's do it crypto 1 here. Crypto 1, so that you can see it is crypto 1. Running it again. Yeah, so it's crypto 1. So it's very simple to change the to add a new business logic. So that's the good thing about this strategical pattern. I mean the business logic is too big, then we can have another way of doing this instead of functional way. Like the previous one, we did it the functional way, like function, payment, and payment strategy. Then this one actually was assigned this value previously, but this is good for if the business logic is just smaller. If the business is too big, then this not very doesn't look very good. It will not be very readable. Then it's much better approach is this one, which is interface way of doing it. Instead of function, we will use here interface, but idea is same. There is a final map class, there is a map, there is a class extend payment, the same idea, because it's dynamically resolved which payment it will be. That's why it is class, as I mentioned before. This is also a strategy pattern. Strategy pattern dynamically resolve which code, which payment strategy to run. Okay, which one. So that's why we need we need a class, unknown type class. So here payment strategy has only, let's understand this code. Payment strategy has only one function method, payment strategy interface, just one process, one method. The all other business logic will implement this process. For example, this is the business logic implementing also, these are also implementing. Let's go through the code little bit. It is simpler than the previous one, as mentioned. So at the beginning, I put the key, the credit card payment class. This is the key, credit card payment. Okay, and this is another one is report, not the report, only these three. 1 2 3. So this is the key, and report is I am generating. So and the value is the new credit part. This is the strategy. This is actually strategy means the business logic. What is the business logic to generate this report? And this credit card payment strategy will implement the process method. See here, this is implement the process method. Sorry. See, implement the process method. Okay. So this is added, and this is statics like previous one. Statics will be running before the main function is run. So it is initialization. So it is initialized, and then we added the list of payment. So credit card payment is a record. So this new record will create a canonical object. It means that it is also immutable, since it is a record. So immutable object will be created. Credit card payment, this object is created. Okay, 3 credit card payment object is created here. 4 actually, 4 is created. So credit card payment is created twice, other one time. So once this is created, then this payment, the payment dot stream, this is created with the, it is basically populating data. This canonical object is contain the data. So data is created. So once data is created, in real scenario, more probably this will be generated from the database. Okay, this data will be from the coming from the database. But anyway, I'm creating at this point. Now here we'll do dot stream will keep the stream. Then stream has the map dot map, and then each one by one. So credit card payment, the first one will be credit card payment passing. So for example, is passing credit card payment to the process payment. So payment this is, think that it is a credit card payment, the first one. Then dot get class strategy dot get class will be the key. Which was the key? Strategy map was the key. This here, the credit card payment class. This is the key. Once I add this key, value will be credit card payment strategy. So the value will be credit card payment strategy. For example, this will be credit card payment strategy. This one. Once this is a credit card payment strategy, so this is credit card payment strategy. Has a process method we previously seen. So this process method is called. The payment is sending. I'm passing the payment to that method. The payment is credit card payment. Okay, credit card payment is sending. This is the strategy, credit card payment strategy. I'm sending the credit card payment. So here, let's see and see again credit card payment strategy. So here is credit card payment. So sending is credit card payment. So here say payment instance of credit card payment and CC. This is a new way of doing the instance of, and at the same time CC means it is assigned. If it is true, and then assign the value to that one, or the credit card it means the credit card payment will be CC. So one statement is the new way of doing it. And then it is simpler, and this amount, it could be very big business logic, this one very big. Okay, not only return amount on 0, and it could be other lot of things. And then you at the end probably you'll create the new payment report. This is the payment report. Okay, this is the payment report, this one record. So at this point, at the end, maybe in real scenario, there will be not only cc dot amount equal to 0, maybe other business logic will be there, but at the end finally it will generate this report. Okay, and then once it generates the report, and this is returning, so the report will be returned who call this one, this call here, it return to here, and it will, and when one by one will process. At the end, this is a terminal operator. We know the terminal operator, when they call the terminal operator, actually at that moment is called each one of them, and then it generated. So it generated, then payment report, it generated the payment report. So payment report is this one. So this record will be populated. Once this is populated, then is just iterate them one by one, and that's it. And in my view, it is simpler, but it is more powerful. Not powerful in the sense that it can have bigger business logic, and it's simpler code than the previous one. But the other code is like, for example, other code also good, but it's if it's small business logic, it uh, more suitable for that. Thank you. Bye.